All right, so I just got some wind to actually continue on with a quick math lesson and stuff. So um, it's not, you know, it's with math problems. It's simpler to have a visual figure and just to have a visual answer. This is the qualitative mindset. However, this is not that's actually not respected to the mathematical process and stuff. The qualitative transformations are perfectly fine and actually very good in like thinking about like business competition, business warfare, and stuff like that. Um, those are definitely very those communicate very well. But what I want to focus on here is the topic of equations and stuff. Everything like there's many types of equations, so we can um, just take a quick look. Uh, yeah, see, so many equations, more than 26. We're like it's like 40 different types of equations in all of mathematics and stuff. I believe it was Hilbert that studied mathematics to completion by by thoroughly mapping all the distinct fundamentals and understanding the variations. He got math down out of context into his system and stuff where he could form syntaxes and stuff, and then that leads to Gödel's incompleteness theorems and stuff. Um, which is a pretty interesting topic and stuff. It's a consequence of an inherent property of limitations of the rules of mathematics and stuff. The thing you think the key thing to understand about mathematical information is that when you have an irreducible term, it has a pre-codified meaning and stuff. It's all based on kind of lookup tables. So there's that, and um, the so now going to just because I have references to chess here on the screen because math and chess are extremely similar and stuff. They have the same um, it's like that same kind of left brain thinking where the states change, it analyzes, the states change again and it reanalyzes. So math, chess, decision making, or decisional analysis, all in the same thing and stuff. And then the subtopic of math game theory, it, like attaches to chess and stuff. It just works and stuff. I would love to develop a first real chess theory and stuff. But yeah, so I think I thought about that the other day. And but anyway, so um, the however, like here I reference his state of the figure and stuff. The figure, however, varies in two neighborhoods. One, you have like the geometric and mechanical equation neighborhood of equations and stuff, like turning wheels and gears, or rotations of triangles and stuff. Derivatives of rotating spheres and stuff. Basically, but what you have to know about this is that it can be easy to qualitatively think about that. However, when you have a certain amount of points assigned to a question and stuff, you have to logically make each point and stuff. So if you're going to have a three-line answer with 5 points and stuff, is that really like is like are you necessarily making a balancing point? Because that's just the nature of the game. Um, and so anyway, so we have this neighborhood of equations, and we just have like the purely analytical equations right here. Um, oh, um, it's like symbolic logic progressions. Yeah. So for this second neighborhood and stuff, um, this is interesting because everything is based on an analysis of it. It's like, okay, this has this content of information which has an equivalence or some relation there and stuff. So with those different relations, like an equivalence, a property and stuff, you're expressing analytically. You're not. There's no. There's no. There's no termination cap on the visual or qualitative aspect of it and stuff. Um, so there's that. So like, let's say we have something like, definitions of a derivative right here and stuff. Right here we could basically reconstruct the foundations of calculus and stuff. Because everything here has deeper content which has a relation, and by conserving the operator here, like let's say I wanted to re-relate x plus h, but by preserving the operator here and stuff, I have a whole new system that I can make. And basically, I would be basing my analysis not off of the rules of manipulating equations like algebras, like your u substitutions, your rationalizing denominators, um, your simplifications, which by the way aren't good and stuff. If you want tactics to flow, you need a superior position. You're gonna need more material on that paper, or on that board you're writing on and stuff, or that research paper and stuff. Work, effort. So, which is why my math lessons take so long to make. And so, yeah, so like going to here and stuff with these relations, you don't want to if you get hung up in the wrong detail, you're going to be grabbing an error, but you don't want error. And so like when you're grabbing an error and the error is over there, you want to focus back on the encapsulations and stuff, and then the implications. And from there, the mathematical expressions become more obvious and stuff, because the implied object and properties are there too. And then from building those properties and discovering those properties, you get the relations. And then you basically applied first principles it's such a precision that you actually have a better mathematical system. You've actually arrived at something that's closer to a changeable case and stuff. So and then like it's been said that that mathematics is bullshit and chicanery and stuff. That was said by somebody with no concept of complex information. That was said by Mark Twain, who thought he knew a lot of things because he went to Yale. And that's a funny thought, because I don't see Yale. I don't think Yale was a school of complex information or knowledge work or anything like that. I mean, like all politics aside and stuff, it seemed that Mark Twain knew so little that he thought he knew everything. It's funny. Anyway, so yeah, Mark Twain should not have insulted mathematicians in any sense of it. That's if there's anything that's more wrong, it's to insult mathematicians. That is a horrible freaking idea and stuff. You know, but bringing it back. So with these relations here, we have all this mathematical content that the mind can generate and stuff. Like in your head, in your mental images, like you have these rates of change and stuff, and these graphs and graphs built on different mathematical expressions and everything. So instead of grabbing an error, we replace that error with actual material where we can have tactics that flow. And then from there, we have, going back to the equation concepts and stuff, basically, there's you get a sense of the syntax and stuff. You might overview the tactics, like, okay, maybe I make a subscript here and stuff. Maybe I possibly fudge factor here, if that's ontological and stuff. But if that's ontological, I would have to forensically trace it back and stuff. And then you have to consider the correctness and stuff, meaning like, are the right variables and properties being tracked and stuff. Like, okay, we went from, for example, we went from counting apples to like now we're gonna fudge factor because there might be pears. Wait, what are we doing with the pears now? The pears, for all we know, the pears were rotten. We got to look at the pears now and stuff, but we didn't even have time to look at the pears. This is because it's no longer correct. It's no longer correct. It might be accurate and stuff, and accuracy is good for the geometric and mechanical stuff. Um, Even some programmatic relations, but not for analytical equations. Not for like your linear programming, um, and solving of theoretical functions and like that. No, no, no. Um, so there's that, and yeah, I mean, so what can be said here about the purely analytical equations and stuff? And then when you want to apply this to the real world, you just adapt and then you go with the consequences and you adjust to the mathematical consequences on basis of theoretical mechanics, basically. Your vectors and stuff like that. Yeah, I think, where are we at? We're at 11, almost 12 minutes and stuff. Yeah, this is pretty long lesson for for something that like kind of covers math directly in a way like you're not just like, okay, just practice this, do this over and over. Not really sure why we're doing this and stuff, but hey, yeah, we'll talk about the purposes of math and what it relates to, and yeah.